when it comes to your speed time graph now, your speed time graph, as you can see, can resemble the distance time graph in terms of its shape, but the interpretation is going to be quite different. Okay, the interpretation of your speed time graph. So we said from the distance time graph, the gradient gives us the speed of the object. What do you think the gradient of a speed time graph will give you? Anybody? What do you think you're going to get from the gradient of a speed time graph? Okay, another question that I have. How did we know that the gradient of a distance time graph gives us speed? If you'll take a little look back at the chat, Rihanna mentioned that to get the speed, you do distance divided by time, right? Or distance over time. So the gradient of a speed time graph. Anybody, tell me what you think you'll get from the gradient of a speed. So I just heard acceleration. Alright, how many people think it's acceleration? Raise your hand if you think it's acceleration. The gradient of a speed time graph gives you acceleration. Let's see. Alright, I see 2 hands up, 3 hands up. Alright, we get a few more. Yes, exercise people, touch the raise hand option now. Do you believe that when you find the gradient of a speed time graph, you are going to get acceleration? And if you just raised your hand or you typed in the chat saying acceleration, then you are correct. Alright, you are correct. So I am very glad to see that there are some people who are somewhat awake and raising their hands into some form of response to say that they agree, because you do get acceleration from the speed time graph. Your speed divided by time gives you acceleration. Now, I mean, from a physics perspective, we know there's a difference between distance and displacement, speed and velocity. Acceleration is what type of quantity? Anybody remembers types of quantities, right? From physics. So when we talk about acceleration, what type of quantity is acceleration? Anybody? A vector quantity. What type of quantity is speed? Anybody? Lovely, it's a scalar quantity. So, although maths does say, well, alright, speed over time is acceleration, physicists might be quite appalled and might be like, oh, how dare you say that a scalar quantity over another scalar is going to give you a vector? But yeah, we interpret it like that. Right, that if we were to get the gradient of a speed time graph, we'll get acceleration, which, like I would say, we know from physics, it's actually supposed to be velocity over time giving you acceleration, right? And likewise, displacement over time gives you velocity, distance over time will give you speed. Okay, so just, the physics relation between travel graphs and the kinematics. So whenever we talk about the gradient of a speed time graph, like I was saying, sadly, mathematics will interpret it as speed over time is your acceleration. Okay? So if ever you want to interpret the acceleration of an object on a particular journey, once you have your speed time graph, you'll be able to find the gradient of any region of your speed time graph, and you could tell the acceleration of the object. So now I have a question about this and then that. What can you all tell me about the acceleration during this period from 0 to, let's just call here, let's just say it was 5 seconds, right? So let's say I told you that was 5 seconds. What can you tell me about the acceleration during this phase of the graph? How many? Ah, lovely. You're building speed. I like that because you could essentially say that you're building speed. You're seeing something happening here. Your speed is increasing, right? Your speed is increasing. So what can that tell you about the acceleration? Anybody, what does that tell you? Say it back again. Okay, so I'm hearing that the acceleration is also increasing. All right, anybody else? Anybody else wants to tell me what can we see about the acceleration of the object between 0 and 5 seconds? What can you all tell me about this region of the graph? That was annoying. What can you all tell me about this region, the acceleration during that region? So we, like people were saying just now, the speed is building up. What can you tell me about the acceleration? Okay, so earlier in the chat, I was asking something about the speed time graph in this particular region between T1 and T2. Ravisha had put a response at that point in time which didn't apply there, right? And technically it applies now. So, alright. So, I'll give you all one more chance. Alyssa, go ahead. I see your hand is raised. Okay. No problem. Okay. So yes. One, yes, your speed is increasing as time is increasing during the first region of the speed time graph. This proportion from 0 to 5 seconds. I'm asking the question, what can you interpret about the acceleration? Okay. Let me ask you another question. If the acceleration is the gradient, right? The acceleration is the gradient of this line. What can you tell me about the gradient along this line? Is the gradient along this line the same, or does it change along this portion from 0 to 5? So raise your hand if you think the gradient along the 0 to 5 region, this region here, tell me, do you think the gradient changes? Raise your hand if you think the gradient is changing along this portion of the graph. Alright. Going once. Going twice. Alright. Alright, Misha, do you have a question? Or are you raising your hand to say that you think the gradient changes? Okay, so Misha is daring to say it changes. Alright. How many people think that the gradient is going to stay the same in this region of the graph? Raise your hand if you think the gradient of that particular section of the graph stays the same throughout that section of the graph, right? And I'm specifically targeting this section of the graph, all right? So I'm talking about from 0 to 5. Do you think the gradient is staying the same in this region? Let's see how many hands go up for that. So I see only like 3 hands go up. I saw Nadia, she was in the chat, and she said during this particular region of the graph she thinks it's constant, the gradient is constant. And alright, put your hands down now. Put your hands down, everybody. How many people write in CXC exams this year? How many people write in CXC maths this year? Raise your hand if you write in CXC maths this year. And I think the whole class is supposed to be raising their hand right now because I just check it, right? So I see about 16 hands going up. How many people want to write this exam and get a 1? And, like, never have to repeat it ever again? How many people would love to just write the exam and not have to repeat it again? Raise your hand as well. So I see, exactly. I see hands up. So why I'm asking this question right now is because what I'm asking you all right now, alright, put your hands down, everybody. What I'm asking you all right now about this little section here, it doesn't have anything to do with something that you do not know. It has everything to do with something you do know. How many people here did coordinate geometry in Form 3? Raise your hand if you remember doing coordinate geometry in Form 3. Alright? And when I say coordinate geometry, I'm talking about you had a coordinate plane, you learned about plotting points and making a line segment, you learned about midpoint, you learned about distance of a line segment, you remember doing something like finding the gradient of a line segment. Because if you remember those things, right, you'll put your hands down, if you remember those things, all those things are actually quite useful and applicable right here. Because the answer to that question that somehow seemed like rocket science is what you do know. That this is what kind of line is this? Anybody? What do we call this in maths? What kind of line that is? Simple. Yeah, there you go. Simple, isn't it? It's a straight line. And what do we know about the gradient of straight lines? Beautiful. It is constant. And if, so do you understand why I'm saying what my question was just now? Although I'm asking about the acceleration, if you know the acceleration is the gradient of the line, and the gradient of this section, if this is a straight line, and the gradient of a straight line is constant, you can tell me the answer to my question. What is happening here is that your acceleration is constant. Do you all understand what I am asking you all to do? I'm asking you all to tap into the knowledge that you do have. This particular section of mathematics or travel graphs is quite simple. Alright? Once you remind yourself of all those basic things that you've learned before. Okay? So, if I ask you all about the acceleration of a body and I give you all the speed time graph, you will tell me during this section here, your acceleration is constant. Simple as that. What do you think is happening here, where we have another horizontal section? So in the distance time graph, we said the horizontal section meant that there was no movement, right? The gradient is 0 kilometers per hour because the body is not moving, so you had no speed whatsoever. But this time, what is happening here with the speed time graph? You have a flat line, yes. But this is a speed time graph, right? So let's say the speed is 60, alright? Or we can work what I have here, 60 meters per second. So if the speed is 60 meters per second, can you tell me what you think is happening here? So I know when I ask you all questions, that's it. It doesn't change. Beautiful. So my speed is staying constant. It's not changing at all, right? So if there is no change in speed, all right, no change in speed, what can you tell me about the acceleration? Right? The gradient of this section is what? So between 5 and 10, we said there's no change in speed. I want you all to make the connection now for the acceleration. We said that the gradient of the line is the acceleration. What can you tell me about the gradient of the section between 5 and 10? Alright, so Chris says in the chat, she says 0. Exactly, 0. So the hand that I have up right now, Ariane, do you want to tell me something, or is your hand up from before? So Carissa just told us that the gradient at this point in time is 0. So if you have a gradient of 0, what does that say about the acceleration? Anybody, what does that say about the acceleration? If your gradient is 0, what does that say about the acceleration? Okay, so I just heard somebody said constant. The acceleration is constant. When did we say the acceleration is constant? We said the acceleration over here is constant, right? Yeah. So what can we say about this section now? If the gradient is 0, let's see what Ravisha says. So Ravisha says there's no change, right? So as Carissa and Ravisha just popped in the chat, they said the acceleration is 0. Exactly, Jaleese. The acceleration is going to be 0 as well, which means, like Alyssa just said, there is no change in the speed. There is no acceleration. Alright, no acceleration. So when we talk about a vehicle accelerating, we're talking about it speeding up. Alright, that is what causes the vehicle to increase in speed. When you have acceleration, a constant acceleration, your body is speeding up. Okay, but if there is no acceleration, it means that you're just moving at the same speed. Okay, an example of this would be, let's say a vehicle on the highway was trying to overtake another. You'd have to accelerate to be able to put significant distance between you and the other vehicle before you could come back onto the lane that you want to get in front of that vehicle on. And then you probably might want to move at a constant speed. You don't really feel like accelerating, so you're just staying at the same speed. So your vehicle is just moving forward at the same speed. There's no acceleration taking place. Alright? And this final piece now. This final piece. So in the distance time graph, we interpreted this piece as a return trip. What do you all think you'll interpret this as? Because here, remember, we're dealing with speed and time. We're dealing with acceleration when we talk about the gradient of a speed time graph. If it is, you have a decreasing slope. Alright? And when I say decreasing slope, this particular type of straight line, this has a negative gradient, so it is decreasing. What can you tell me about the motion of the vehicle during this final phase here? Waiting, let me hear. Alright, so let's see what Nadia has to say. So Renita, go ahead and listen to you. Alright, the final piece of what you... Right, so the final piece of what Renita said there. So deceleration is something that takes place. So the physics say deceleration during this period where you notice that the slope is negative. This is what you call deceleration. Alright, or as she was saying, it's slowing down. And if you all look in the chat as well, Nadia was saying that it's slowing down until it stops. And as Ravisha also mentioned, it'll be coming to a stop. So this little piece of the graph, this last piece here, is telling us that the body is now slowing down. All right, it's coming to a stop. So this could be something like all the time he driving fast, he getting vexed because the man in front of him taking too long, so he decides to overtake. So he overtake. Now he have, some good clear area in front of him. He decides to just drive at a constant speed, and then realizes that he's approaching a traffic light and decides to start slowing down because it was on amber, and well, he has to stop completely because it's a red light now. Okay, so those are some sort of scenarios that you could see distance time graphs being applied in real life. Alright, so your distance time graph, your speed time graph, as we just discussed. Alright, so those are the two types of traffic graphs that we're going to be looking at in particular for CXC. There are questions, like I was saying, where you'll have a distance time graph or you might have a speed time graph. So the reason why I was asking you about all those things was just to make sure that you understand how to identify your distance time graph versus your speed time graph, and the analysis in particular where the slope is concerned. Now, earlier, when we had just started talking about our distance time graph, and I was asking about the speed of the object, Calissa was mentioning the area under the graph. However, the area under the graph does not, in the case of a distance time graph, give us the speed of the object. The area under the graphs will in fact give us very important pieces of information concerning the journey of the particular object, and here's how they work. Alright, so if I wanted to find the area under this particular graph, this distance time graph, this doesn't really give us speed, and what you'll actually get under this distance time graph is just distance by time. Alright, so it doesn't tell you anything in particular. It doesn't really give you like a speed, for example. It doesn't tell you, let's say, like total displacement or anything. But if you were to look under your speed time graph, under the speed time graph, you would be able to get something out of it. Alright, so under your speed time graph now, the information that you'll get is that of the total distance covered. Why I put M for, I have no idea. Alright, yeah. So under your speed time graph, you will get your total distance covered. Okay, so if you have to find the total distance covered on a journey and you have a speed time graph, you're talking about the area under that graph. But if it is you have a distance time graph and you want to know the total distance covered, well, that in particular comes out of being able to interpret your graph itself, because remember, it's distance versus time. Okay, so the area under a distance time graph is going to be not giving you anything important, but the area under a speed time graph will